Thank you for coming to our talk today. I'm Lawrence Lai, Senior Business Development Manager at FutureWay. And my co-presenter, I have a co-presenter today, Rakesh Jain. He's a Senior Technical Staff Member and researcher from IBM. And our talk today is about, topic is the SODA architecture for data and storage management. Okay. So SODA Foundation or SODA project is a project under Linux Foundation. We're developing software solutions for data storage management. It was launched in 2020. It's almost 2 years now. Our members largely consists of vendors and also end users. For our project, our mission is to try to develop an ecosystem that for open source based data storage management software. Also, the other goal is to provide a vendor neutral platform that allow cross project integration, collaboration, and our aim is to provide a end-to-end solution, and not just developing a spec, but an end-to-end solution that end user can actually deploy into their data center. And end user is very important for us. Actually a lot of roadmap requirement came from end user. Besides that, they also provide use cases, test cases, and when we have releases, we do POCs, they provide feedbacks. So it's very much involved through the process. We have an end user advisory committee. They meet regularly. They provide guidance to the board member, also TOC, Technical Oversight Committee. As you can see, there's some members from the end user advisory team. They work for large companies, manufacturers, or telcos. Those companies, they have a lot of experience managing a large amount of data on a daily basis. Just a brief history on SODA. SODA actually came from a project called OpenSDS. So when we started OpenSDS project, the reason we started this is try to solve end users' storage challenges. One of the challenges they're facing was that typically those end users deploys several various brands of storage from different vendors, and to prevent single vendor lock-in. And these storage systems come with their own storage management software, and typically only the software works with their own branded hardware. Typically doesn't support other storage array, which makes when end users deploy that into their data center, makes it very difficult to use the resource efficiently. So it creates a kind of storage silos. And so they cannot use it efficiently, and making relocation very difficult, very challenging. And also, more and more, these end users have to support internally they have to support like cloud native applications, like new container applications. The container cloud native comes with its own storage API, CSI, as most people know. But however, CSI has very general support for storage. And some of the advanced features for these enterprise storage cannot be utilized. You just simply use CSI interface. So those are the challenges we're facing for OpenSDS. So at the old project, OpenSDS, we think that to solve that problem, there's three things we should do. Instead of using complex admin-centric API, we should use unified, user-friendly APIs instead. And for very complicated configuration, which should be replaced by policy-driven configuration operations. CSI situation, instead of treating all the storage the same, we think it should be, the unique feature of the storage should be enabled and utilized. So the end result, we had this project, OpenSDS, we have an architecture that can basically solve end users' problem. We have a controller in the middle, it's a policy engine, policy driven, and then we have northbound APIs that can connect to CSI or also Sophos compatible. And underneath we have like a docking system that various docks can support various enterprise storage and also cloud storage, also different file systems. Adding a new support is very easy. You just basically write a plugin to add that in. It will be automatically supported. At the end of OpenSDS project, I think we was quite successful and end user pretty happy about that. But then we also learned that the fragmentation doesn't lie in the storage alone. Also, all through the data management kind of process has fragmentation. So based on the end user requirement, we decided to expand the project and rename the project SODA. So here's today our project composition, right? There are basically two types. One is the called SODA framework project. Those projects are kind of developed internally within the community. And the other type of projects are SODA Echo project. Those are the external project, existing projects that we integrate and collaborate with. So in terms of our own community project, SODA framework projects, there are three projects. One is called Strata. That's a kind of multi-cloud data management project. It's cloud vendor neutral, using S3 APIs. Can be used for hybrid cloud, intercloud, or intra-cloud. And the S3 compatible API allows you to deploy the project either in the cloud or on-premise. And then we have another project, Delfin, which is a heterogeneous storage monitoring project. So it provides performance, alerting functionalities, and also you can customize it and then adding a kind of customer client for visualization or data processing. And then the TERRA, which is the SDS controller, came from OpenSDS project. It basically can support traditional workload like OpenStack, VMware through plugin. Also can support Kubernetes and through CSI interface. So those are the three existing framework projects. So we constantly listen to end users and also watch out trends and try to understand what's coming. And so and based on those research and requirement from end user, we develop new projects. There's two new projects. One we're developing this year. One's a Kahu, which is the container data protection project. And another one's called codename Como. It's a Multicloud Datalake project. And Rakesh will come up and talk in more detail on these two projects, explain it later. And so our future direction is very much kind of towards cloud native. Because we draw that conclusion through surveys and also research, and then we'll have more projects to support cloud native down the road. So besides our own data framework project, we're now trying to reinvent the wheel, and we recognize there are a lot of existing external projects related data storage management project we can collaborate with, we can integrate with. So we create a program called SODA Echo Project Initiative. And so right now we have about 10 projects. We constantly looking for a new project and reach out and try to enable and work with them. So currently we have 10. Just a few examples. YAG YIG, it came from China Unicom. This is kind of a Ceph cluster-based, and so it's for massive scalable object storage project. Currently, YIG is being deployed in China Unicom's data center. Another project is Deos, came from Intel. This is it's a software-defined scalar object storage. It's for the HPC applications. And then LinkStore is another project. It came from, what's the name of the company? Limbit, sorry. Limbit, so it's a software-defined storage solution project for managing block storage for Linux server clusters. Okay, I think next. Mukesh will talk about more detail on the Delfin and other projects.
All right, so basically, we are trying to create an ecosystem of all the data storage projects, open source projects, basically. So LinkStore is one of them. So going back to what Larry mentioned in the beginning about Delfin. Delfin is a heterogeneous storage monitoring project. And I think this picture actually tells you everything what it does. Basically, you want to monitor different types of storage systems, meaning different vendors actually. That is the most challenging part about it. That different vendors have different ways of accessing their systems and their monitoring data. But that's what we are trying to converge into Delfin. And not only storage, we want to include switches and servers as well. So basically, all the way from server to the volume, you should have a full data path available through Delfin. In fact, the vision is, that is actually the current state. The vision is that we want to get the application level details as well, so that you can actually see that which application is using which volume from which storage through which switches. Any change you want to do in the data path, you would know which application is going to get affected. So that's the vision, and I think we are moving in that direction very nicely. This is actually in use in production in a couple of companies right now, but it's still in heavy development. Now, what are the internals of Delfin? So as I mentioned, resource monitoring of all the different devices, whether it is storage systems. So we started with storage. Basically, we monitor our pool, volume, port, network controllers, everything within the storage systems. Trying to map out the whole topology of the SAN environment. So that's the configuration part of your storage. Then what else we have is also the performance monitoring. This is where it's quite challenging when you're dealing with heterogeneous storage systems. But at least, at top level metrics we can get, which are most relevant, like IOPS, response time, read latency, write latency, and those kind of things, and capacity, of course. In addition, we do alert management. So the idea is that, get the alerts from these different devices into this Delfin, and from there you flag it out. Advantage here is that you can actually act on, you can correlate alerts, coming from different devices. Now, we haven't gone there yet, but that's the plan, that if you can correlate alerts and make some sense out of it, that would be very useful. So once, first thing is then get the data. So that's what we're doing. The driver manager is where you actually plug in your different drivers for different storage systems, different switches. So that's kind of standard. I would say people tried to standardize it for a long time. There always have been challenges, but so far we are going on a smooth ride. So let's see how it goes further. And then there is this plugin manager that is basically, if you want to export the data from Delfin into some other tools like Prometheus, you can write exporters for that. In fact, the Prometheus exporter comes by default because that's what we use. But yeah, any other kind of exporters you want to write, that's kind of interface available. So yeah, what we have is a few interfaces, like configuration interface, which is responsible for giving all the configuration, meaning registration of drivers and all that, which storage you want to monitor and all that, right? So that all goes through configuration interface, read and write. Then there is query interface. If you want to query the performance data of any specific device, you can do it through Delfin. There is a DB interface, which is kind of, if you want to replace the database we are using, you can use the DB interface for that. And then there is exporter interface I just talked about. Besides that, there are certain modules within Delfin, like resource manager, task manager, and alert manager. I think, yeah, they do their own things, as the name suggests. And yeah, the driver manager. So that's basically high level the architecture of Delfin. I have worked on storage management products before. This all is based on cloud native now. The advantage is that you can scale up, scale down things as needed. In the past, that wasn't the case. You come up with huge requirements that you need this much resources to install this product, and then as your devices grow, you have to grow the whole thing. But now it is much simpler. You just scale up only the component you think are needed to be scaled up. So with the Kubernetes-based implementation, it is actually much simpler and modular. This is all the same stuff we just talked about, so I will skip this. So yeah, in summary, and in fact, most of the projects in SODA framework projects, they are written in Go. This is the one written in Python. For some reasons, initially, when they started working on it, they found that Python was easiest to go with for different drivers, because the team, in fact, wrote drivers for certain existing storage systems, not by the vendors. So they started with those because there were some open source drivers available which were doing similar things. Right now, it is agentless for the work it is doing, for what I described. So there is no agent installed. And yeah, of course, it is fully open source and vendor neutral. Basically, the pluggability of the drivers and the export of metrics, that all is what is available today in Delfin. Now, what is the plan? Next, what we want to do for Delfin? As you're probably aware that today, in the cloud native world, the storage is kind of not that well monitored. So people who have developed cloud native storage, they have very good monitoring for those things, but not for the regular storage. So that is something we are trying to get into. and that would be through some kind of monitoring agent, which will work alongside the CSI driver. As you probably know that some of this stuff is probably going to go into CSI drivers. That takes time because, of course, CSI has to take care of a lot of other things when they deal with such a large ecosystem. So whatever goes there, we will deal with it when it comes. But right now, we will have our own monitoring agent, which will push the data into Kubernetes. And I think everything else is quite standard there, whether you're using Grafana, Prometheus, and Kafka and all that, right? So with that, for Kubernetes, I think we will have, again, heterogeneous storage visibility there in Kubernetes with unified visualization reporting for cloud-native storage, and all the good stuff you can think of. So that's high level what we are thinking of getting into next for Delfin. And then, yeah, we do have to research certain other things which we are thinking of, which is including the federation support and real-time performance and cloud observability and all that. Okay, so that's Delfin, which is basically heterogeneous storage monitoring project. I think this is one of the very few open source projects in that field. So if you're interested, you can go to the Soda Foundation website and see if you want to attend the meetings and join. You're welcome to do that. Okay, next we will be talking about Como. So Como is, oh, by the way, if you have any questions, feel free to ask anytime. Como is a multi-cloud data lake. Now, actually, it's multi-cloud virtual data lake. So not really, we are not actually creating a huge data lake. So we go into data virtualization. As you probably know very well, that the companies have all kinds of data in all different sources and locations, right? In different formats. And even multiple data warehouses or data lakes, just because maybe acquisition or whatnot, right? So there are many reasons they have this setup. And now they're going into multiple clouds. So it is very difficult today that how do you actually get an overview of your whole data set? And especially if you need some sort of data, you have to figure out where do I go and get it, and then all the access requirements and all that, right? So data virtualization actually helps in here. It is supposed to integrate data from disparate sources without copying or moving the data. So that's the key here. And it gives a virtual layer that spans multiple application formats. So that's, at the high level, what is data virtualization. It does not normally persist or replicate the data, from the source systems, normally. So the only thing it does is that it stores the metadata information about the virtual views and the integration logic, that how it is going to get the view the data from the source. And the main use case here is that it actually is aimed at producing very quick and timely insights for small sets of data from multiple sources. So we are not talking about doing large analytic kind of work with this kind of thing, but it's mostly how do I get access to the data from disparate sources without copying the data. Now, based on that, we do have this project called Soda Como. This is actually, as Larry mentioned, that we work with end users, And one big end user company, actually, they came that, we have data in multiple clouds, and it's very hard to figure out what is where, and it's very difficult, actually, to do access management and all that. Especially when we have to give access to the users to do, whatever analysis they want to do. So they wanted some solution in that space, and then after a lot of discussions with a lot of other end users and other companies involved, we launched this project. This is still in design phase, actually. Not any development is done yet. So if you are interested, please feel free to join. It's very early right now and right time to join. Yeah, so basically we have, you get from GCP, AWS, Microsoft, or your own data centers. This is going to connect to all these different sources for your account and get the metadata, what is stored where and how. And then we'll give you one view. Now it does show here AI, ML, and all that. I know for that you will need the data. And if, in case you need the data, it will get the data. So that's the exception here. But right now, the objective is actually to clear up the authentication, authorization pieces, and actually to locate the different data sources or the type of the data. So that's what Como is about, and I think in this year for phase 1, we are targeting object storage only in a couple of cloud providers. I think there's 3 cloud providers, the hyperscalers there, and yeah, the most important part there is RBAC for the access management thing. And I think, yeah, this actually shows, so the company I was mentioning about, that's SoftBank. That's from where the requirement came, and I think we are still going back and forth with a lot of clarification, but this is what is going on right now in SODA community. It's a very new project and still in design phase. This is the high-level architecture. So one thing I like about working with so many different projects within this sort of foundation is that you kind of standardize on architecture, like how you want to do things. So it's very easy actually to start a project. You have to have an API gateway with standard set of unified APIs for whatever you are doing, and then you put in other microservices, because it's all microservices based, to do specific jobs in the specific project. So this is basically what we have right now for Como. So you would see that there is a data mover service as well, that if it is needed, we have to move data. And if you have to do caching, there's cache service, and the usual stuff, basically. And then, yeah, the lower part that's where the drivers come in for different cloud providers. Okay, yeah, so that's all from me. Any questions? Yeah?
So what was the object of having that Como set up that you guys are in phase 1 on? What's the final game you're going to get out of it?
In the phase 1?
Well, what's Como going to do?
Yeah, the Como is basically giving you a view into all your different storage sources. So basically, if you want to find certain data and you don't know where it is, you would come to Como, because what it is doing actually is that it is connecting to all the different cloud providers, at least, for example, and for your account, and letting you know that, okay, this data exists here, this data exists here, and the data could be in different formats. So it does the conversion on the fly.
Okay, so if I had an in-house storage bunch of different storage clusters and stuff like that. Let's say Luster,
Yeah.
GPFS and BGFS. How would I be able to implement Colo
Yeah.
to help out there too? Because you keep talking about cloud, but I'm just wondering, so does have other setups.
Correct. That's why I think we are starting with this simple one, which is object storage in the 3 cloud providers right now. That is more challenging. I totally agree with you. We haven't got there yet. But according to the vision, we will get there. And that's what data virtualization also does, right? Okay. Any other questions? If not, I think we have to finish on time, I guess. So, Larry. Ecosystem.
Okay. Last thing I want to talk about a little bit about SODA ecosystem before wrapping this up. I think so. Ecosystem actually for open source based project is very important. Besides development, you need a kind of really robust ecosystem to make the project successful. So we work with various organization companies, and I mentioned end users, right? So end user they provide roadmap and requirement, such as the Como project, SoftBank case, they provide requirement, things like that. Same for other projects, and they do testing, adoption, provide feedback, etc. And we also, of course, have developer community help actually build the projects, write the code. And then we have a vendor in the community. They build interoperability solutions that test various components around the projects. Of course, also another key important component is the other organizations, industrial organizations, for example, SNIR. We sponsor those events. We collaborate with, support their standardizations, certifications, and also do co-marketing. And then we also have university, academia partnerships, working with them for lab testing, internship, or doing researches. So we also, because our goal is to provide end-to-end solution for end users, so we need to understand the trend, what's going on. And make a decision based on the research. So we do, for example, we're doing this data storage trend survey since 2021, collaborating with the Linux Foundation Research. And that's some highlights from 2021 research. And all those information are public on the website you can find. And this year we continue to do that. It's actually, we just wrapped this up. We have a weekly call with Linux Foundation Research right now working on right now it's closed. So we're working on the report and result analysis. And the result will be out, shared to the public in October timeframe. The other thing we do is a hackathon. Together with other projects, so we did the first hackathon this year. 1 month long in March, and then at the end we had a 2-day event to kind of showing demos and also, demo and also company that share about their projects and also announce winners. And so we got about 10 projects involved and contributed to the hackathon. So that was quite successful. We'll continue to do that next year. And before pandemic, we do a lot of these face-to-face events, kind of like today, worldwide. Those are some pictures from some events in the past, before, even during pandemic, some limited face-to-face events we went to. And we have this event called SODACon, which is our annual event. It's like a whole day event, talk about SODA-related things. So last year we did a virtual one. I think the last 2 days. So it was quite good. We have over 700 plus attendees, and we also had a lot of sponsors. Support us. So that was great. And this year we tried to go back to in-person, face-to-face. And so we plan to have in Yokohama in Japan, December 7th, in the end of this year. We're always looking for developers are very important for us. We're always looking for a developer to join us, collaborate with us. So if any of you interested to work with us, please check us out on Slack. Join us on Slack. That's it. Very much. Thank you very much for coming to this talk. And if anything interesting from today's topic, please find out more information from our website and reach out to us. Thank you. Any questions? No? Okay. Thank you. Thank you very much. Thank you.